हेलो एवरीवन एंड वेलकम टू दिस चैनल। तो आज हम लोग करने वाले हैं एनालॉग इलेक्ट्रॉनिक्स 1 में हमारा अगला टॉपिक दैट इज कॉमन एमिटर कॉन्फ़िगरेशन ऑफ अ ट्रांजिस्टर। तो यहाँ पे हमारे पास डायग्राम है फॉर अ कॉमन एमिटर कॉन्फ़िगरेशन एंड वी आर यूजिंग आवर एनपीएन ट्रांजिस्टर हियर एंड ये हमारा पहला जंक्शन है दैट इज नोन एज द कॉमन बेस जंक्शन एंड वी हैव आवर सेकंड जंक्शन हियर which is known as the emitter base junction. This is our input voltage and this is our output voltage. Now हमारा main objective होता है that a transistor should behave as an amplifier and we know that for the conditions of amplifier we will have to operate the NPN transistor in active mode. So active mode के case में our junction 1 is forward biased and junction 2 is reverse biased. तो उसी के हिसाब से हमने यहाँ पे हमारे voltages assign कर दिए हैं. So we are calling the input voltage as VBE and the output voltage as VCE. अब इसी पर्टिकुलर डायग्राम को हमने थोड़ा डायग्रामेटिकली चेंज किया है एंड हियर वी हैव आवर एमिटर, हियर इज द बेस एंड हियर इज आवर कलेक्टर. सो IB current is entering, IC current is entering here and IE current is leaving from here. अब इस पर्टिकुलर पार्ट को हम लोग बोल रहे हैं VBE वोल्टेज एंड दिस पर्टिकुलर वोल्टेज इज कॉल्ड एज द VC वोल्टेज. सो पूरे डायग्राम में हमारा इनपुट करंट है IB, हमारे इनपुट वोल्टेज है VBE, आउटपुट करंट इज IC एंड आउटपुट वोल्टेज इज VCE. Now we know that IE is equal to IC plus IB, which is by applying the KCL law. And here we have been studying this equation from the first video, that is IC is equal to alpha times IE plus ICBO, where ICBO is the reverse saturation current. अगर हम यहाँ पे अब IE की वैल्यू को रिप्लेस कर दे IC plus IB से, so we will have our equation like this, which is IC is equal to alpha times IC plus alpha times IB plus ICBO. तो हम लोग क्या करेंगे अब that we are going to just move IC towards the left side. So we will have our equation like this, which is 1 minus alpha times IC is equal to alpha times IB plus ICBO. अब हम चाहते हैं that we are going to divide the whole equation by 1 minus alpha. So we will have the equations as IC is equal to alpha times 1 minus alpha into IB plus 1 by 1 minus alpha into ICBO. अब अगर यहाँ पे हम लोग alpha by 1 minus alpha को beta मान लें, so if we do a mathematical solving that is beta plus 1, then we will have the value as alpha by 1 minus alpha plus 1. We will have the value of beta plus 1 is equal to 1 by 1 minus alpha. So we can replace 1 by 1 minus alpha as beta plus 1. So we will have a final equation as IC is equal to beta times IB plus beta plus 1 times ICBO. अब यहाँ पे हम बात करें अल्फा और बीटा के रेंज की. So alpha is always less than 1 and beta ranges from 50 to 400. अब लेते हैं हम लोग हमारा केस 1 that is alpha is equal to 0.98 and जब हम ये वैल्यू बीटा में डालेंगे we can see that beta is equal to 49. If we take the case 2 when alpha is equal to 0.95, then we get the value of beta as 90. So we can see that with only a slight change in alpha, हमारा beta बहुत ज़्यादा largely vary करता है. Now after this, we can consider this whole part which is beta plus 1 times ICBO as ICEO, where C is common emitter and O is for open circuit. Now we will have our equation as IC is equal to beta times IB plus ICEO. Here beta times IB is much greater than ICEO. So we can just neglect this term. तो हमारे पास इक्वेशन आ जाएगी IC is equal to beta times IB. So from here we will have the value of beta as IC by IB. And here beta is known as the current amplification factor. This common emitter configuration हमारा एक current amplifier की तरह काम करता है. So here is one example that is IB को हम लोग 1 मिली एम्पियर मान लेते हैं and beta is equals to 100 मान के चलते हैं. So अगर हम यहाँ से कलेक्टर करंट कैलकुलेट करें that is IC is equal to beta times IB. So IC हमारे पास आता है 100 milli ampere and you can see that the current has amplified by a large value. So that was all for this video and I will see you in the next one.